Good afternoon, students. I'll start with the class. In the previous class, we had started with definite integral. And there were some properties of proofs which we had done. Two of the main proofs, which is out of 4 marks, were left. So those I'll do today. You can consider I think five proofs I done. The next one, these are 4 marks. The proof is 0 to 2a f of x dx, which is equals to 0 to a f of x plus f of 2a minus x. I told you it's the same proof but can be asked in 3 ways, or 0 to 2a f of x dx equals to 2 times if is equals to 0 if f of 2a minus x is equals to minus f of x, or 0 to 2a f of x dx is equals to 2 times 0 to a f of 2a minus x dx if f of x is equals to f of 2a minus x and equals to 0 if f of x is equals to minus f of 2a minus. Is the same proof, can be asked in 3 ways. Let's start with the proof. This was already given to you in the previous class. Same thing, if not written, just copy it later. Let's start with the left hand side. This is the proof. 0 to 2a f of x dx. As per property number 5, which we had done in the previous class, okay, the last proof which was done, you can always split these intervals into two parts. We had seen that. Suppose a to b we have, then it can be splitted as a to c plus c to b. Like one term in the middle you can introduce and that you can continue. So any one interval can be splitted into two parts, but you have to continue the same letter here and then the third one. So as for that, we'll split this into two parts. One 0 to a f of x plus then the next one will introduce from a to 2a f of x. Finally 0 to 2a I'm splitting into two parts. 0 to a and then a to 2a. So this is your first integral. Can consider. This will consider as the second integral. Now this substitution you have to remember what I'm giving you next. In the second integral, we are not doing anything with the first one because 0 to a we have normal f of x dx. Don't do anything to this. But this is a to 2a. We have to do something so that we arrange it in this form. So this one a to 2 in second integral. Put x is equals to 2a minus t. This substitution you have to remember for this proof. In the second integral, put x is equals to 2a minus t. So this is the substitution. And I told you, anytime we substitute, we have to differentiate it also. So this will be dx. Derivative of 2a will be 0 because it's a constant. And derivative of this will be dt. So finally, dx is nothing but minus dt. Okay. Now we have to resubstitute. Means this entire integral we have to write in terms of this. Before writing, again, whenever there are limits, you have to change the limits also. So over here, what is the value of x? When x is equals to a, we have to check what is the value of t. So when x is equals to a, we know that these are the limits of x value. But now we have to write in terms of t. So when x is equals to a, put in this main equation, put x as a over here and check. Substitute instead of x, put a and calculate the value of t. So we know that when x is equals to a, t is also equals to a. When x is equals to a, t is equals to a. Now we'll check when x is equals to 2a. In the main equation, put x as 2a and so we'll get t equals to 0. 2a minus 2a will give me 0. So when x is equals to 2a, t is 0. We'll write the integral back now. So what is the left hand side? This thing. First integral, I'm not doing anything. As it is, I'm keeping. Only the second integral, entire thing I have to write in terms of t now. So when x equals to a, what was the value of t we got? T was plus a. So t equals to a only. But when x was equals to 2a, what is the value of t? 0. What was the x value? F of 2a minus t. And dx was how much? Minus dt. Now minus, I'll bring it out. Using property 2, which we had already proved in the previous class. If we are having minus, you can use this minus. You can change the limits. So minus I can apply here. I'll make this plus. And minus if I apply here, this will reverse. It will become 0 to a. In the last step, if you see the proof, everything we got, only this instead of t it is x, but we can always change the letters as per property 1. What property 1 says? The proof 1 says that all the letters can be replaced. Instead of t, everywhere I can use x. So 0 to this plus there's a dx, 0 to a, f of 2a minus x. This is equals to my right hand. So it's the first part is proved. So what we got? Therefore, 0 to 2a f of x dx is equals to 0 to a f of 2a minus x. This is the main equation. Okay, if you have used already that one, use this as 2. So whether the first part of I gave you this proof in 3 parts, something or something or something. Anything is asked out of those 3, irrespective, don't even go to think. Till this point you have to prove anyways. Whether first is asked, second is asked, or third part is asked, you have to get this only. Just as it is, you have to write. Till here, if only the first one was asked, then we got the proof, we have to stop. Nothing else to do. So this is your main proof. Now comes the other part which was given. Suppose if the second part is asked to prove. Okay, so I just write it as case 1. We have to do this proof on first, with whatever is asked, irrespective of that. So to prove 0 to 2a f of x dx is equals to 2 times 0 to a f of x if is equals to minus. So till this part I have to prove, and then this extra part also I have to prove. So what I'll do is I'll take this first condition. Put this condition in equation 2 and see what you're getting. They've asked to prove this is the answer if f of 2a minus x is equals to f of x. So if this is there, we'll just try to put here and see. So what will equation 2 become? So instead of f of 2a minus x, I'll put this. Isn't it the same thing? Same it is. So 1 plus 1 will give me 2. So we have proved this. Now, the second part, this one. We'll check if f of 2a minus x is equals to minus f of x. Put again this condition in equation 2. So 0 to 2a f of x dx is equals to 0 to a. So instead of 2a plus x, I have to put this as minus x. This minus will come out. So it is going to cancel, and this will be 0. So if you ask this proof, this second type proof, do till equation number 2 as it is, and then these extra 2 steps you have to show. Anyhow, whichever part is used, I told you, till equation number 2 you have to prove. And then extra whatever is in R. Now the case 2, the third part. If you have to prove 2 times f of 2a minus x dx, if this is ulta given. And this you have, but this is anyway 0. Huh? 0 into that will be anyway 0. F of x is equals to minus f of 2a. This is the third part was given. If this proof is asked, okay, same thing. Prove till equation number 2 only. Now take this first condition. Put this in equation 2. So now what you have to do, wherever there is f of x, you have to put this. Right? You know that equation number 2 is this. In the previous first case, we had replaced this. Instead of f of 2a minus x, we had put this. But now, instead of this, I have to put this value. So instead of f of x, I put this. So it's the same thing. So it will be 2 times. This condition is asked. F of x is equals to minus of is minus. So in this equation, put minus. Put this condition in equation 2. Then this cancel, so it equals to 0. If it is plus, it will get added and become 2 times. But if it is minus, it will cancel and become 0. So this is a third way the proof can be asked. So any of the 3 is asked, finally you know that you have to prove till equation 2 and only extra this substitution, whatever condition they ask, put it in equation 2 and prove it. The last proof for that. Before the proof, I'll tell you what is an odd and even function. What is odd function? As per definition, it is f of minus x is always equal to minus f of x. Example is consider minus x cube. Minus of x cube will be what? Minus will come out. This is called as odd function. Even function, even f of minus x is positive only. F of x, no minus coming out. Example, minus x square is still x square only. x square is an even function and x cube is an odd function. How do I know? Just replace it by minus and see if minus still remains out, then it's an odd function. So now you know that what is the condition for odd function? F of minus x is equals to f this minus of f of x. And for even function, even negative, outside it will be positive. So this condition you should know for odd and even. So based on this, the next proof. This is the seventh one, I think. Minus a to a is equals to 0 if f of x is an odd function. You will get it 2 times f of x if it is a even function. So we'll take the left hand side. Now this minus 2 plus, okay, we'll split it into two parts. From minus a to a, I'll split it into two parts. The middle part will be 0. So what I'll do is, first interval I'll take from minus to 0 and then from 0 to a. I'm splitting this integral into two parts. So this is first integral. This is second integral. The second integral is as it is 0 to a f of x. We don't have to do anything. But if you notice, these limits are slightly different, not 0 to a. So we try to change this integral. So over here, what I'll do is, in integral 1, we'll put x equals to minus t. The substitutions you have to remember. In first integral, put x is equals to minus t. And now we have to find the derivative. So this will be, once you differentiate, you know, this is dx and this is minus dt. And you have to change the limits also now. Because when you want to write the integral back in terms of t, these limits are for x. But you have to find limit for t now. When x is equals to minus a, put x is equals to minus a and check. So t will be equals to a. When x is equals to 0, t equals to 0. These limits you have to put it in equation 1 and see what is the value of t. So when x is minus a, t is also t is a. And when x is 0, t also is 0. So we'll write this integral back. Left hand side. And so minus a to 0, now it will be a to 0. x is equals to minus t and dx is nothing but minus dt. Now this minus minus you cannot multiply on. This is inside a function, so we don't know what kind of function it is. If it was simple minus t, you can multiply, but this function of minus dt, this you don't multiply to each other. This write as it is. Now this minus will come out here. Using property 2, use this minus sign. So this will be reverse now, 0 to a. It should always match with this one. And now everything you make in terms of x using property 1. So what was the left hand side? We'll get this equation 0 to, sorry, minus a to a. Mark this as equation 2. That's our main equation. Now there are some conditions given. First one, in the question, now you check in the proof what was given when f of x is an odd function. So f of x is an odd function. I told you what is the condition? F of minus x is equals to minus f of x. Put this in equation 2. So instead of f of minus x, you'll have to put it as minus f of x. Just using this minus. Minus will come out for odd function. You know that is going to cancel now and will become 0, which was asked to prove. Whenever it's an odd function, answer should be 0. That equation 2 will become 0. Next is when f of x is an even function. F of minus x is equals to plus x only. Now put this in equation 2 and check. Equation 2 will become minus x will become plus only. It's the same thing, so it will get added, become 2 times. So you have proved it. So when f of x is an odd function, you get 0. And when f of x is an even function, then you get 2 times tan. You now will solve some problems based on the properties. This is pi by 2. Huh? Now these are with limits. Okay, some functions are there. What you have to do is take that as I. Now I will use property number 3. Okay, these are using the properties. Now later once you see this type of problems, you'll understand that you have to use property. Sin x upon sin x plus cos x. With limits if it is there, normally you have to use the property. So I'll use property 3. What property 3 says is 0 to a f of x can also be written as 0 to a f of a minus. A means this is the limit. You can just replace it by this number also, a minus x. Whether I write it as a minus x or f of x, answer I get it same. Last time we have proved it, property number 3. So with that logic, I'll apply the property here. So wherever there is x, I can always replace it by a minus x. See, x, I can simply replace it by a minus x. A is nothing but your upper limit because this is anyway 0. So what I'll do, instead of this now what it will become, x can be replaced by pi by 2 minus x for this problem. The value of a is pi by 2. I'm not doing substitution as such, I'm just replacing it as per the property. You don't have to differentiate nothing. So the entire integral, what you do is, wherever there is x, just replace it by pi by 2 minus x. Everything I'm just replacing it by a minus x. So that's why it will become pi by 2 minus x. Everywhere pi by 2 minus x. Because as per the property, I can do that. It means the same. Mark this as equation 1, okay? Whatever question is given, that is always equation 1. Now you know that sine of pi by 2 minus theta is always equals to cos theta. Same way cos of pi by 2 minus theta is sin theta. Same applies for tan. Tan of pi by 2 minus theta is cot theta. Always they are 90-degree different from each other. Even sec of pi by 2 minus theta would be cos x. So as per that logic, sine of pi by 2 minus this is nothing but cos. Again, sine of pi by 2 minus x is cos x. And cos of pi by 2 minus x is sin x. Mark this as equation 2. Now add both the equations. greater than, this is also I only. Add equation 1 plus equation 2. These are fixed steps. Huh? So left hand side will get added, I plus I. Right hand side also will get added. I will added equation 1 and 2. If you see, both have the same common integral sign, so I can take the integral common. This is anyways 2I. I'm just taking the integral out common. So what remains is sin x. Cos x. I made the integral common because limits are also same. Now if you see, denominator is same. Sin x plus cos x is same as cos x plus sin x. So denominator I'll make common in the next. So if denominator is common, numerator will get added. Common denominator. And if you notice, both are same. So they will give the problem on in such a way that this will cancel. Now what answer we get is 1. The integral of 1, you know, it is x. The moment you integrate, you know, you have to put the limits. Yeah. And how to solve a definite integral? Always substitute the higher limit minus the lower limit. Wherever there is x, put higher limit first. Middle sign is minus, then put the lower limit. So 2I is equals to pi by 2. I will be pi by 4 is the answer. Second one. 0 to pi by 2. One upon 10 cube x dx. So 10 cube, what you do is write it as sin cube upon cos cube. Then you cross multiply. After cross multiplying, you'll get like this. Cos cube x plus sin cube x upon cos cube, and then cos cube will go up. After cross multiplying, you'll get it as cos cube. Mark this as equation 1. Now use property 5. I can just replace it by a minus x. Property, sorry, 3. So for that, wherever there is x, just replace, same like the previous problem. Only there's a cube there, doesn't matter. Everything will get replaced by pi by 2 minus x. Again, the same logic. Cos of pi by 2 minus theta is sine theta, and sine of pi by 2 minus theta would be cos theta. And because there's a cube sign, everything else also will get a cube. Cos cube pi by 2 minus theta will be sine cube theta. Ulta it becomes cos becomes sine and sine becomes cos. Mark this as equation 2. Now add both the equations. Same steps you have to follow. The left hand side I plus I, on the right hand side first equation, that is cos cube x upon cos cube x plus this. Take out the integral common. Same integral sign. This will be 2i. The problem I know, it will be always given in such a way. Denominator is same. Whether you write a plus b or b plus a, doesn't matter. So it's a common denominator. So it will always get cancelled and get it as 1. Integral of 1 is x. And then same like previous problem. Pi by 2 minus 0. So I will be pi by 4. So instead of 3, even if the power was 5, 10, fraction, 3 raised to any power they can ask. 5 also, 10 also, but finally it gets cancelled. And answer will get the same. So power will not matter. Third one, suppose if the problem was given like this. Root is there. So whether it is in the root sign, whether it is cube root, any power doesn't matter. So I have to take this as I. This is 1. This will be root cos x upon root sin x. And then cross multiply. We'll end up getting like this. Mark this as equation 1. Then use the property. Everything will get replaced by sine of pi by 2 minus x we will get this as 0 to pi by 2. This will become cos x. This also will become cos x. This will become sin. And then follow the same, leave space for that. You have to do the same step, add equation 1 and 2. And they will get added, everything will get cancelled. What remains is finally 1. Numerator and denominator will cancel. Final answer will be same like previous. I will be pi by 4. One second. Next problem. Fourth one, this will be, suppose if we have pi by 6 now. Now this is not 0 to a, this is a to b. Okay, before that, we just simplify this. Root 10x can be written as pi by 6 to pi by 3. This is n is 1 upon root sin x upon root cos x. Then cross multiply. So you'll get this root cos x upon cross multiply, and then this will go on top. Mark this as equation 1. Now, what we have to do is, now this is not 0 to a, this is a to b. So I'll have to use property 4. What they say, a to b f of x dx can be written as same. A to b can be replaced by a plus b minus x. This is property 4. 0 to a means property 3. A to b means property 4. What it means is x can be replaced by a plus b minus x. As per that logic, what is this? X can be replaced by pi by 6 plus pi by 3 minus x. Pi by 6 plus pi by 3, if you check, is pi by 2 only. X can be replaced by a plus b minus x. So a plus b is anyways pi by 2. They give only the number such that it will always end up as pi by 2. So everything again same thing will get replaced by pi by 2 minus x. Or I can write it this way also, pi by 3 plus pi by 6 minus x then only one step will increase. You'll get this only finally. If you add these two, you'll get it as pi by 2. That is a plus b minus x. Everything you have to replace wherever there is x. Now same thing, cos of pi by 2 minus theta is sine theta, and sine of pi by 2 minus theta will be cos theta. Sorry, this is sine x. Mark this as equation 2. Now add equation 1 plus 2. This will be again pi by 6 to pi by 3. Equation 2. Now the integral sign is common. Take out the common integral sign. Now make it common, and then it will get cancelled, and finally you'll get it as 1 only. Because common denominator. Here it has 1 dx, and you know integral of 1 is x. You put the limits. The only difference here is it is not 0 to pi by 2, it is pi by 6 to pi by 3. So higher limit first minus the lower limit. Across multiply. Two I will be 3 pi by 18. So 6 to 2 I will be pi by 12. Next problem. Suppose if you have it in terms of numbers, okay, okay. If this is I, okay. Now mark this as equation 1. Again, we'll use property number 5 now. Just check the numbers, huh? Property 4, I think. Just check. Previous problem also. Number you don't this focus. Just focus on the property. This the property which I'll be using is a to b f of x dx. Numbers might change, shuffle from here and here. I might not remember which number. But property, obviously, I will not give a wrong one. So a to b, just check the number and write them. So it has to be replaced by a plus b minus x. Same as the previous problem. I think by mistake instead of 4, I must have given it as 5. So just see and then correct the number. That's it. So same thing, x can be replaced as a plus b minus x. If this was 0, then the previous property of a minus x. But there is b also. So as for that, I can replace it by 2 plus 5 minus x. X can be replaced by 7 minus x. So wherever there is x, I have to replace it by 7 minus x. So everywhere in this problem, instead of x, I have to replace it by 7 minus x. This also. Now here you have to be careful. Already this 7 is there. This minus is also there. Now x I am replacing it by 7 minus x. So use a bracket. Instead of this x, I have replaced it by 7 minus x. Now open up the bracket. Minus or minus will give me plus. This is equation 2. Add equation 1 plus 2. 1 and 2 you have to add. This is equation 1. This is of equation 2. And this is x. Make the integral common. Then bring them together, they will cancel out each other. Then will cancel and give it as one only. Same denominator. We will get 2y equals to x from 2 to 5. Substitute the upper limit minus the lower limit. That will be 3 by 2. Next question. This is different from other, but you have to use property at some point. We have to find integral of 0 to pi by 4 log of 1 plus 10x. So whatever is the question given, we'll take it as I. Now it is 0 to a. So I'll have to use property number 3. A, so x can be replaced by x minus a, oh sorry, a minus x. So x can be replaced by pi by 4 minus x. So wherever there is x, I replace it by pi by 4 minus x. Okay. Tan of, use this formula, pi by 4 minus theta is 1 plus tan theta, sorry, 1 minus tan theta upon 1 plus tan theta. This formula I'll use. If it was plus, this is plus, this is minus. So this is minus, this will be minus. Whatever sign is it will go to the numerator. If this was plus, this would be plus, and this would have been minus. So tan of pi by 4 minus theta is tan 1 minus tan theta upon 1 plus tan theta. That's why I will become log of 1 plus 1 minus 10x upon, and now you cross multiply. The answer will be 0 to pi by 4. We know that log of a upon b is log a minus log b. This is log of a upon b form. I'll write it as log a minus log b. Just separate out this integral sign to both the terms. Just give it to this one also. Integral sign I separated out to both the terms. If you notice, look at your equation 1. What was the question given? In the question itself, it was this. This is back. You ended up back to your main question. So instead of this, I can use I here. So for equation 1, the value of log of this, I had assumed it to be I. And this log 2 is a pure number. So log 2 I can always remove out. If it was log x, I cannot take it out of the integral sign, but it is log 2, so I can always take it out. And this is mine. This is I. Take I on the other side. Integral of x, 1 is x, 0 to pi by 4. So substitute higher limit minus lower limit. And 2 will come down. Some pi by 8 log 2 is the answer. Next one. 0 to 1 x square root of 1 minus x dx. So I'll use 0 to a it is, so property 3 only. Can be replaced by a minus x. So a is 1 here now. So wherever there is x, I have to replace it with 1 minus x. Wherever there is x, I just put it as a minus x. This is x, there is a square, that's why the whole square it will become. Now a minus b, the whole square formula is a square minus 2ab plus b square. Open up the bracket. So 1 and minus 1 this. So instead of using u into v, what I can do, root x, there's a multiplication sign, so I directly cannot integrate. But root x can be written as x raised to half. Multiply it inside. So this will be x raised to half. X raised to this into this will be 1 plus half. Powers always get added when you multiply. Integrate this. So this is x raised to n formula. After you solve, this will be x raised to 3 by 2. This will become 2 by 3. Cross multiply. 2 into 2 by 2, 5. 5 by 2, so that will be 2 by 5. This will be 7 by 2, so 2 by 7. After reversing, I'm writing up. And then wherever there is x, put 1. Zero. Anyways, this is all 0. 1 raised to anything is 1 only. And find the LCM, calculate the value, and then you write. This is plus, no? The answer will be 16 upon 105. Okay. With this, I finished the property-based problem. Just one small problem was left. One this step I not done. I'll do that. It doesn't not from the property. Starting just one miscellaneous question. 1 to 2, 2x plus k suppose is equals to 5. Then find value of k. So we have to integrate this. What is been given is 1 to 2, 2x plus k dx is equals to 5. So we'll have to integrate this. So integral of 2x is, this will become x square by 2. If nothing is there, means it is k into 1. K is a pure number. This will be kx. If this was like 10, then what we would write integral of 10 is 10x. Because nothing is there, the sign means it's always assumed to be 1. The integral of 1 is always x. Now wherever there is x, put 2. This n will cancel. And then minus wherever there is x, now put 1. Lower limit. This will be 4. Will be 2k minus 1 minus k. 2k minus k is k plus 3 is 5. 5 minus 3, so value of k is 2. So if any time like this is asked, you have to solve the right hand side and equate it to the left hand side accordingly, equate and then find the answer. So with this I finished with integration chapter. Okay. Those who had not attended offline class and had seen the first video, no, they had told us 18 marks. So the 18 marks of last year, the first video I had sent. Okay. Now this time because of the two boards, they have reduced the mark. So they made it as 12 marks. So integration is of 12 marks. So whatever I've covered till now has 12 marks for board exam. Now Sunday one class is enough for me because very few things are there. I'll be doing applications of integration. That's considered as a separate chapter. So that is of 4 marks. Just one problem comes on this for 4 marks. So please attend this class because surely you'll get 4 marks. Now for those who don't, at least the basic integration you should know, not the types and all. Those types, even if you don't know this particular what is integral of x also and what is integral of 1 also you don't know, then anyways it's gone, 0 you will get. So with this I'll finish the chapter on Sunday, the entire integration along with application of integration. As of now, integration chapter is over. Now what is left is applications of integration. Whatever college questions they do for internal and all, try to practice. If you don't know, you can always say the difficulties.